Hello, my name is Craig Little. I'm one of the sales engineers in the Pacific Northwest, and I want to talk to you today about live kernel patch. Let's walk through a quick demo of it. You can see a variety of the tooling, and then we're going to also look at SUSE Manager a bit so you can see how SUSE Manager can come alongside of live kernel patch and really provide a very, very powerful solution set. So as if you guys were just new to watching this demo, or if you were part of the tutorial session where we were talking about kernel live patch methodology, we're going to go finish taking a look at the demo portion, and we're going to go take a look at the various commands associated with kernel live patch, zipper, and a little bit of SUSE Manager. So the first thing that we want to do is we kind of want to validate that we have kernel live patch enabled. So one of the first things that I would do is we're going to do SUSE connect status-text, and that's going to tell me, interrogate system is going to tell me in list what modules we have deployed. We can see that my kernel live patch module is in place. So that's a good start. We can also do a zipper list repository, and we can see right here, I know it's kind of a messy list, but we can see that I've got the kernel live patching repositories enabled. So I got a yes for the pool, and I should have a yes also for the updates. So I know I've got kernel live patch enabled. So there's those two things. So I've got access to the source. I've got the subscription piece activated where it's a good start. Now, if I do uname -a, the final piece of this here, I can tell with this LP right here that the live patch kernel is actually installed on this system. And we're going to keep track of the fact that this is a 197.15 version of the kernel. This is a SLES 15 SP1. I keep it around just so I know there's lots of updates available for it, lots of fun things to go practice and test with. So we're going to take a look at one more zipper command, and it's zipper lifecycle. And if you haven't heard of this or seen this, it's kind of a cool little command, especially if you are using it as part of your ability to go see what's on a system and what has updates available and what doesn't have updates available. Again, a little bit older system, lots of updates available. But if we go look here, so zipper, we got all the zipper pieces in. We're going to go scroll up. We're going to go look for the kernel packages. We're in the libs. Let's make sure we don't overshoot. And so we can see right here is I've got the kernel live patch for 197.10 and 197.15, and lo and behold, there's an update. So we can go ahead and execute this update. So we know that we have an update available. But if we kind of scroll to the very top, there's some other additional good information here, which primarily on this one gives us our product end date. So something to kind of keep in mind. Zipper Lifecycle is a very cool tool. So we're going to skip down to the end. I know I have an update available, but let's take a look at the KLP command. And I'm just going to do --help so we see all of the pieces that are available for it. This is the tool that we can use to manage or help us manage kernel live patch. So we got statuses, patches, and blocking. So we'll do the verbose, and we'll start with status. So we're ready. Kernel live patch is ready for us to drop some new updates in. So we'll do a KLP -v patches, and that'll tell us what is currently been deployed. So I've got one patch, the 5_2_1, which you can tell what version of the kernel, and we can see the CVEs that this particular one answers. So some very good information. And the last one was blocking. This is useful if you've deployed a live patch and you want to verify that it had finished updating all of the threads There's no threads with the KLP in progress set. So we know that the previous patches have been executed and it's all clean. So we're good to go on deploying a new kernel. So now we're going to go back to our zipper commands. -s kernel -live. And this will give us a quick list once we do a refresh of the repositories here. This will give us a quick list of the live kernel patches that are available. And notice we've got a whole slew of them here. These are the source packages. If we scroll up, we can look at the various packages here. So we can see I've got updates in all of these various kernel revs. If you remember, we were at 97.15. So let's scroll up to the 97.15 and 97.15. So I've got, this is the one that's installed, the 5.2.1. Looks like there's a 6, a 7, and an 8. If we want to go ahead and install the 8, we can go ahead and do that. But notice you can see with that search command with the -s gives you a lot of details to where you can see all of the specific versions that are available. So real quick, we're going to jump back down to the bottom and we can zipper in kernel -live patch -4 _12 _14 -197 _15. So that's the kernel version -default. So we're going to zipper in that patch. So zipper install. And it tells us down here, once we get down to it, it loaded the repository data, install packages, package dependencies. It's saying there is one package to upgrade. So we can go ahead and answer yes here. And that's going to upgrade my kernel to the live patch version 8-2.1, which if you remember back on the zipper lifecycle, showed that we had that update available. So it's executing the post-transaction script. Everything looks good, and we are done. No reboot required, because if we scroll back up, remember Zipper's pretty good about telling you if a reboot is needed before having you answer the yes command. It's just a particular package is going to be upgraded, and away we went. We did all of the install, so now remember the KLP commands. So we'll do the verbose, and we take a look at patches. We now have the 8_2_1 with all of the various CVEs that it answered. So we know we have all those pieces in place. We've got all of those vulnerabilities fixed and taken care of with no reboot. Again, we can do status. We can see what's going on. We got a ready and blocking. There's no threads. Again, lightly used system here. It just went and executed. I have live patched my environment, quick and easy. Now, if we do a zipper up, standard straight up zipper up, and we hit OK, notice here, it is wanting to do a new kernel. So it's looking to do the kernel default and take it up from the 197.15 to the 197.78 version. And this is going to require a reboot. This is problematic when you're running in a high uptime requirement type of application environment. So we're going to go ahead and answer no. So standard zipper up will break the live update kernel or the live patching of the kernel work that you've been doing. Each of those kernel revs have a year life cycle that they will be patched. So you're going to want to kind of match that up with when you deploy it, so you know you've got about a year before you're going to do a reboot. And so it will be patched inside of that year cycle. If we want to upgrade to the new kernel, great. But we don't always want to upgrade to that new kernel because we want to just continue doing the live kernel patches. So in order to fix this, what we're going to do is we're going to use one of those little known zipper commands. So we're going to add lock, and we're going to add lock for the kernel default. Specified lock has been successfully added. So we're going to now do a quick list locks, and we can see kernel default is locked. So now, if we do zipper up one more time, notice all that's in here now is the kernel firmware to be updated. The kernel itself is not going to be updated. There's other things that are saying it's going to require a system reboot, but we're gonna fix that in a little bit different way. And notice the following two items are locked and will not be changed by any action. So it's locked my kernel, so I can't update to a newer kernel. One methodology of ensuring that just doing a zipper up isn't going to break the environment and cause a reboot. Now, by breaking the environment, mainly I'm referencing the fact that it won't cause a reboot. So we can lock the kernels, but that's really a very system-specific type of solution set. But notice, this is really very, very simple tooling to allow you to accomplish a very, very sophisticated patching environment and give your users and your application owners that kind of uptime that they really are desiring. So we want to go ahead and I am going to abort that. Did not mean to hit yes on that one. So I may have to go do some work on this system and to take care of this piece. But what I want to do is show you inside of SUSE Manager a very cool feature that allows you to work with kernel live patch in a very cool way. So that feature is the content lifecycle. So we're going to expand that out. And the content lifecycle feature of SUSE Manager allows you to manage what patches and packages are available to a system based on features. And we're going to take a look at this SAP landscape. And the primary piece that I want to show you here, this happens to be a SLES12 SP4 base channel. But as we scroll down, we see the SLES12 SP4. We have filters here that allow me to say, allow these particular filters, but deny these particular filters. And right here, deny reboot required kernel patches. This effectively takes care of what we did with a locking the kernel without having to lock kernels, without having to go touch a whole bunch of systems. I just built a filter to filter out those particular patches and allow live kernel patches, and away I go. So this accomplishes on a very large scale what we had to do at a very detailed system level quickly and easily. And then with SUSE Manager, it allows us to push content from SUSE Manager as well as utilize the standard zipper commands to have the system pull that content. So it's a nice little feature of SUSE Manager that works very, very well with the live kernel patching to be able to give you a really, truly effective patch management methodology that's integrating your standard patches and your live kernel patches all together and minimizing the potential for breaking environments by requiring reboots. So that's the demo that I wanted to do. Hopefully you learned some things today and had fun walking through these pieces. I look forward to catching up with you guys on a live kernel patch, one of the meetups that we'll do here in SUSECON. And hopefully you're having a great day with SUSECON, or a great couple of days with SUSECON. Have a wonderful time. Bye now.